because today we're dealing with fractions. If you have fractions that are being added or subtracted together, you have to have a common denominator, meaning the bottom of the fraction has to be the same. If it's not the same, you have to make it the same so that it looks like this. Here are your two examples. You can add these together because they both have a common denominator of 10, the same denominator. You just add the top part and then keep the denominator the same. So 1 plus 7 is 8. 8/10, simplify it if you can. Likewise with subtraction, got to have the same denominator. Then you subtract the top part, but leave the denominator the same. Simplify if you can. That's elementary school. Fresh you what you should know. Today we're going to have to find some common denominators because we're using our exponent rules for some stuff with fractions. You have the same base and multiplication. You just wrote this down on your do-now paper. What do you do with your exponents? Add them. Keep the base, add the exponents. So we're going to add the exponents. Write down the rule. We are adding 1/2 plus 1/3. Shoot. Do you have the same denominator?
Nope.
So you can't add them yet. You have to get a common denominator, which we could think of as like the least common multiple. 6. To get 2 to be 6, what do you multiply by? 3. You have to multiply in the top and the bottom of the fraction, so multiply by 3 on both the numerator and the denominator. How do I get 3 to be 6? What do I multiply by? 2. Oh, I'm glad you didn't forget everything from elementary school. So now you rewrite your fractions. You are doing not 1/2, what is it now? 3/6 plus 2/6. Add the top, keep the denominator. What is that? 5/6. So we're actually simplifying an exponential expression though. So go back and get a final answer. X to the 1/2 times x to the 1/3. You added your exponents, so your final answer is x to the 5/6. You added your exponents together. Cool. Same rules we've been using, just don't be afraid of the fractions. Second one. When you have power to a power, what do you do with your exponents, please? Multiply. Write it down so you know what's happening. So it's not just a bunch of random fractions written down on your notes. We're multiplying. What exponent does 2 have? 1. So remember we're multiplying to both of these. Well, 1 times 5 is easy, so we're not going to worry about that. But when we have 1/2 times 5, I'm going to write that out to the side. Five is not a fraction right now. What can I do to make it a fraction? Over 1. When you multiply fractions, you do not have to have a common denominator. You just multiply straight across. I don't know if any of you went to Kellybrook. I did not, but my former 5th grade teacher, Miss Stanley, used to teach at Kellybrook. Yep, she had me. Yeah. And I remember in 5th grade, we were learning how to multiply fractions. And I just could not get this for the life of me. And I don't know how many times Miss Stanley said it prior to this, but eventually it clicked and she was like, just multiply straight across. That's all you have to do. 1 times 5. 5. 2 times 1 is 2. It's just 5/2. Great. So if you just have one number, you just multiply to the top. Multiply straight across. You don't have to worry about common denominators. It's fine. So now when you do your power to a power, yeah. It's 2 to the 5th and then v to the 5/2, 5/2. We've done enough of this by now. You know that you can't leave it as 2 to the 5th. Does anybody remember? What is 2 times 2 times 2 times 2 times 2? 32. 2 to the 5th power. So here is your final answer. So multiply your exponents. Make sure you evaluate coefficients. And then last thing, Same base, division. What do? Not divide, you subtract. If you have coefficients out in front, you would divide those, but your exponents, you'll subtract them. So we are doing 1/3 minus 1/6. Shoot. There's no common denominator. What would it be, though? Just 6. You only have to multiply this one on the left by 2 to get that. So 1/3 is the same as 2/6 minus 1/6. 2/6 minus 1/6 is 1/6. So your final answer would be written, keep the base the same, subtract the exponents, 1/6. The first two lines I filled up for you. If you have a denominator, the bottom of the fraction is 2. It looks like x to the 1/2. In radical form, that's just a regular square root. You don't have to have anything in the crook. 2 to the second power is 4 because we're doing 2 times 2 is 4. And so, since 2 times 2 is 4, the square root of 4 is 2. The next line, x to the 1/3, that's written as the cubed root, so there's a little 3 in that crook. 2 to the third power is 8 because 2 times 2 times 2 is 8. And so the cubed root of 8 is 2. I want you to try and fill out the rest of the table at least up until here. So at least through 7. You will not have anything for these last two boxes for the nth root. I should have deleted those, but I didn't. Okay, try it. Go. Hopefully you noticed by now whatever number is in the bottom of the fraction goes in that little notch of the root, the radical. So it would look like this. So that means that whatever number n is on the bottom, that's what goes in that little notch. On the last two columns, we should have 2 to the 4th power is 16. So what is the 4th root of 16? Oh my goodness, it's 2. Okay, 2 to the 5th, multiply by 2 again, and you get 32. So the 5th root of 32 is? Wow. All of these answers are going to be 2. 2 to the 6th, multiply by 2 again, and you get 64. The 6th root of 64 is 2. And 2 to the 7th is 128. So the 7th root of 128 is, yes, 2. This guy, that's your regular square root. And then this one is for any root, especially ones that are, I would say, for sure 3 or higher. You could use the cubed root for 3 if you want, though. So 1/2. When we have 1/2, look at your little chart. Your root is just going to be the regular square root of 100, which I hope by 9th grade you know what the square root of 100 is. What is it? It's 10. It's 10. Because the square root of 100 is 10 because 10 times 10 is 100. If you want to put a little reason, that's why. Also, fun fact, you could also do -10 because -10 times -10 is also 100. Okay, that's an easy one. You should not need your calculator for that. Hopefully we can do that in our head. This one, oh no, you could do in your head. Before we put it in our calculator, let's rewrite it. Where's that little 5 going to go? if I have this root of 243, where does the 5 go? This little notch right here, right there. Write it down. That's what we're evaluating. I want to know what number times itself 5 times gives me 243. You might be able to figure that out in your head. If not, though, we use our calculator. This is equal to 3. Write it down. That's how we put in our calculator. Great. What do you think the square root of negative 25 is? Try it in your calculator. Square root of negative 25. The square root button is above x squared. You still have to click shift to use it. So it'd be shift and then x squared is where that is. Negative 25. Make sure you use the negative button and not the subtraction button. It's going to tell you, what's it say whenever you type in the square root of negative 25? Non-real is what you should have. Non-real. This does not work. No real answers. You can't take the square root of a negative number. This is called an imaginary number. So if you have an even root, it doesn't work. How about the cubed root of negative 8? Find out for me, what is that? You could either use the cubed root button, which is above the parentheses, or you can use the any root button, which we just used a second ago. Negative 2. Here's why. Negative 2 times negative 2 times negative 2 is negative 8. So notice the difference between these. You can take the root of a negative number if it's an odd number here. If the number is even, like we had here, it was a 2, that is not allowed. Last one. I want the 7th root of 16,384. Type it in. 7th root of this very large number. 4.